Hi, and welcome to the last section in the Terraform chapter, which is modules. This is a bit of an end-of-level boss section at 30 minutes long, so I'll try and ramble as little as I possibly can, and we're going to get a lot of good stuff crammed into it. There's no room for me now on the same screen as this diagram because of all the great stuff we've learned, so let's have a quick recap. At the moment, we're connecting a provider to AWS and using resources to define what we want to spin up. We're defining variables in the variables.tf file and providing them values from TF vars. The resources can define specific values into the TF state using outputs, and then consume those outputs from other TF states using external data sources, which can also be used for a whole host of other external data types. Right, let's make our final change here. At this point, I'd be lying if I said the diagram was that useful in and of itself, as it's become a bit too complex to understand at a glance. But trying to understand what's going on just from file names is even worse, so let's give it a go. Now we've added the concept of a root module and child modules. If we get rid of most of this diagram, other than those two concepts, you can see here that the root module contains defined module blocks, each of which calls a child module, which contains a collection of resources. The terms root module and child module are new, so let's define them in simple terms. The root module is the folder we run Terraform commands in. You may not have been aware of it, as it wasn't relevant to mention until now, but all the examples we've done so far in this chapter have been using just the root module, with all our resources defined directly inside that root module. A child module is a reusable set of some combination of resources, with all the values you might want to change variabilized out. A child module is purely a tool of convenience. In industry, when we think of spinning things up in Terraform, we're probably going to think of spinning something up like a web server, or even a product of some kind, such as a client website. These things are composed of more than one resource. For example, if we think of a simple web server, it would still require an AWS instance, a security group to allow web traffic, and also, quite likely, an elastic IP address for the external traffic to be pointed at. It may well have other parts too, such as a Route 53 DNS entry, though we'll keep it simple for now. There might be hundreds of times that you want to create a web server for some reason or another, with slightly different settings each time, so it makes sense to combine these components together into a set that can be called as a single unit, rather than having to create all three resources from scratch to a root module every time you want to write one. It also allows you to keep some level of isolation between each component, and in very large firms this can even include keeping complex child modules in different Git repositories altogether, developed on by different teams. When I say module during this course, I'm going to use it as shorthand for a child module. If I'm talking about the root module, I will specifically say the root module, which is common parlance amongst teams I've worked with. This final chapter is going to use one of the most commonly used layouts in industry, that of environments calling a child module. You'll see how that pans out shortly, but let's take a look at what we're aiming to build first. We're going to build three servers: a server that only allows HTTP, a server that only allows HTTPS, and a database server. Of course, in reality, you wouldn't separate HTTP and HTTPS onto different servers, but it's nice for an example of how we can change different features. We're going to make it so that each server has a security group around it that only allows traffic on the appropriate port. And we're also going to limit where that traffic can come from, so the web traffic is going to be allowed from absolutely anywhere because that will be your customers, but only the two web servers are going to be allowed to communicate with the database server, and no other traffic will be allowed through. Aside from the fact I've split HTTP and HTTPS, this is a classic front-end, back-end pattern, and one we'll come back to in a couple of the other chapters as we progress through this course. Right, let's jump onto our VirtualBox Linux VM and get started building it. As always, if you haven't been following along and creating the code yourself, all of it can be found at the Lernard GitHub repository and is free to clone or download. So, we'll start by CDing into the Terraform repository folder, and then we'll open that same folder in Visual Studio Code. Unlike the previous sections, as this section is the last in the Terraform series, we're going to create the whole thing from scratch to show how super hardcore we've become. The other reason for this is that this setup is going to be a bit more complex, so we're going to build it up in parts, bit by bit. First, let's create a directory called Section 8. And then inside that, we'll create a folder called Modules, which we'll use to store each of our child modules in. The structure I'm using here is not only common in industry, but also quite closely based on one of Terraform's own recommended layouts. I'll keep things fairly generic at this point, so I'll create a new directory for a child module called Module A. The first thing to get used to about working with child and root module format is that what we were previously doing in a single folder, the root module, looks more like what you'd now find in a child module. So we're going to make a main.tf file here for our resources, just like we've been doing before in the root folder. Due to the larger size of this section, I think we'd both go a bit peculiar if you had to actually watch me write it out word by word. So I'm going to cut and paste things in blocks now, and then explain each one. If you're looking to follow along with me, then prolific use of the pause button is going to be your friend here. You'll recognise this first block as a resource for a standard AWS server, with all the particulars described in variables. It's currently referencing a security group called Security A, so let's put that in next. There we go. There's our security group called Security A. The ports are variabilised, but the CIDR block is hard-coded to allow traffic from everywhere, because we're going to be using this module for our web server setup. Finally, as it's a web server, let's give it an elastic IP here too. You'll probably notice this is all stuff we've done in previous sections, so copy and pasting is definitely an option, like I'm doing here. As we had all sorts of variables in there, our next step is to create the variable definitions to go with those. So, here's some I made earlier. That's another thing I tend to do in my actual Terraform work. I'll just add variables for everything, then go and create them at the end. You don't have to worry about forgetting any, as if you do, Terraform tells you quite specifically when you try and run it, and you can go back and find them at that point. In fact, it's worth mentioning that obviously in these videos, if I get an error, I go and fix it and then re-record the section. But in reality, when you first make Terraform code, it would be very surprising not to have made any mistakes. And the Terraform plan we keep running will pick up what those mistakes are and suggest an idea how to fix them in many cases. It's a great, lazy way to code, to just have a best guess about what you should be doing, and then keep iterating over the words Terraform plan until your code eventually runs. Anyway, now we've got our variables, let's save all this and then create a file called outputs.tf. And in this file, we're going to output the security group ID of the module like so. It's with child modules where outputs really come into their own, when we're going to cross-reference them in other modules. You can see I'm using the Terraform internal name of Security A here to specify what it is I want to output, and that matches this name here in main.tf. Right then, that's it for our module A. What you'll probably have noticed here is that there are some files conspicuously missing from what we've been used to. There is no provider and there is no backend, as these aren't required in child modules because they're going to be configured and passed through from the root module. As we're busy making child modules, let's make another one called Module B, which is going to be used for our database server. Again, create a main.tf file in it, and we'll paste in the same code for a server that we used the last time, along with an accompanying security group. The important thing to notice this time is that to define who is allowed access to this server, instead of a CIDR block of 0000 to allow all traffic, we instead have the line here for security_groups. This does pretty much the same thing, but specifies that only the members of other security groups can access this group on the specified ports. As you can see, there's a variable here, as what we're looking to do is provide access only to the web servers we spin up, and currently they don't exist yet, so we don't yet know what the ID of their security groups is. I'll just quickly change these to say B to distinguish them. As before, we now need to define all the variables we're going to use in this child module, so I'll just copy and paste them in here like so. Okay, so we've made a beautiful pair of child modules, and we now want to call them. To do that, we're going to create a root module, but even more exciting than that, we're going to name our root module after the name of an environment. One of the big themes in DevOps that a lot of you will be familiar with already is this idea of environments, which are identical copies of the same collection of servers to the ones that you allow customers to visit for the purposes of testing. A simple setup for this might be dev and prod, where prod is short for production, where all the customers will give you their money, and dev is development, where you check stuff works before promoting it into production. With that in mind, let's create a folder called Environments. And in there, we'll make a folder called Dev. Each environment we create here is going to be a root module, so that being the case, we're going to need to create a backend this time. We'll use our standard Lernard backend bucket as it served us well so far, and we'll give it a key of dev. Let's quickly save these, as I forgot to. There we go. And now we'll create our main.tf and provider.tf. The provider has standard AWS provider settings in it, like so. Just the name of the cloud provider and the region. And now we're ready to fill in our main. As we've created two child modules, we want to call one of them now with a module calling block. So the first thing we do is write the word module. Now we give it a name. And again, as with all names after a component, this is the name Terraform uses to reference the calling block. To tell Terraform where the module actually is that we want to reference, we're going to use the word source. Inside the quotes, we specify the path of the module relative to the current location we're in. So in this case, it's up 2 levels to take us back to the Section 8 folder, then into the modules directory, and the module we're calling lives in the module A directory. Now, the way modules work is that once you've specified which module you're calling, the only thing you need to do is fill in the variables it's expecting, and that's it. All the resources are already declared in the module, so we just write out each variable the module is waiting on in turn and give it a value. That value can be either hard-coded, or it can be a reference to another variable, or it can even be interpolated, which means inserted from somewhere else, such as a calculated variable or value. If you've forgotten which of the variables this module is expecting, don't worry, you can find it by just looking at the variable.tf we created, which is a record of everything that it's expecting to be fed in. If a module has a default value for one of its variables in variable.tf, then it means you don't necessarily need to give it a value in the calling module because it already has one it can fall back on. So, let's specify an instant type. A number, which will just keep as 1. We'll variabilize the environment here for reasons which will soon become apparent. And we'll give it a port of 443 because this is going to be our HTTPS server. Lastly, we'll give it a name, which we'll just call var.name for now. As always, we need to declare our variables. I'll just dump these ones in here, and notice that I've given an environment value of dev by default. We'll also create a few tfvars values here. Let's do type, number, and section. Actually, come to think of it, we're probably not really using number at the moment as I've hard-coded it, but let's leave it in as we might use it later. OK, so let's quickly recap. We've created 2 child modules that are ready to be called when needed, and we've created a dev environment folder as our root module that will do the calling. In that, we've made a module calling block to module A and thrown in a load of good variable values to feed into the child module. Now, let's hop over to our terminal and see the result of all this when we run our golden Terraform commands. First, we'll cd into our newly created dev environment. Now, Terraform init. Notice here how, unlike in the previous sections, where Terraform init was just downloading plugins, it's now also initializing the modules that we're calling. This is important as it would mean if we later go and change a module, we would need to reinitialize. If you forget, Terraform will remind you anyway, but still worth knowing. Great. Now, as always, Terraform plan. Some of you may by this late stage be missing out the plans and just doing the applies in your own work, especially bearing in mind that it has a confirmation feature built into the apply, and of course for your own home environment that's fine as there aren't any customers to lose if something horrible happens. But honestly, it really pays to write plan every single time in a professional environment. Firstly, you'll probably be paid by the hour, so waiting for those plans to complete will be winning you precious extra pennies for no extra effort. But more importantly, as a DevOps engineer, you might be dealing with things that really matter to the world. We're not talking about some website for a discount carpet company here. No one like that is going to be able to afford you anyway once you complete these courses. This could be critical government services, tax or defence, or an international corporation that takes millions an hour. A bad mistake could cost the company more than an ordinary person could ever make back in a single lifetime, so it's always worth sparing that extra few minutes and do a plan. Right, micro rant over, and there we go. Notice in my case it says 1 to change, as I've left some stuff in there from when I was playing around. But don't worry about that, it's still good to go. Yours will probably say 3 to add though, which is the 3 things we've defined in the child module we're calling. So, Terraform apply. And it's done. Let's go and check out the AWS console to see what it is we've got. As you can see, our machine is there. Nice and simple at this point, so we don't need to poke around too much. Let's go and get some more code in and keep building up our model. I'll just clean up my tabs here. There we go. That was our HTTPS server we made. And if you remember from our diagram, I also wanted to make another server security group elastic IP triplet, but this time to only allow for port 80. Well, now because we're using modules, all I have to do is copy and paste here like so. I'll change the name to HTTP, and I'll change the name variable of the first module to HTTPS just to distinguish it, and the second to HTTP. Another thing we've mentioned before, but notice how as I'm now using quotes around the name to combine a string with a variable, I've had to start using $curly brackets to show that it is a variable. That was pretty quick compared to the first part. Let's run that through again here in the terminal. Unusually, I'm going to do a Terraform destroy here first, as Terraform has a quirk that it can hang if you rename a security group, due to the way that AWS handles security group removal rules. In fact, it's not that uncommon for a Terraform run to fail, because some component or other needs deleting. You might expect to come across stuff like this every couple of months or so in your first job, and for reasons like that, everything should get done in test first. In any case, this destroy will have fixed things for us, so now let's do a Terraform init. And now a Terraform plan. And now that's done and saying 6 things, a Terraform apply. Great! Notice how easy it was to make our second web server. It was just a case of making one block to call our pre-existing module that spins up the 3 things we wanted, and that's how it should be. Modules can take a bit of time to get set up right, but once they're done, it makes replicating those things a doddle. Let's have a quick glance back at our console. And yes, as you'd expect, you can see that both servers are now happily chugging along there. So, if you remember this diagram from our introduction, we've so far created the 2 web servers, open to the outside world, on their respective ports. Now we want to create our database server and make it only accessible to the first 2 servers and no one else, on port 3306, which is the MySQL default port. Again then, let's open up a module block to call our module, and I'll give it the name MySQL Database. This time the source is module B. I'll specify a type for it here. I'll give it a count. And lastly, I'll give it the name DB. Now, if you remember, we added a variable to the module itself to express the security groups we wanted to whitelist. So let's go and grab that here. And now we'll add it as an option to feed some values to. We'll open a pair of square brackets, as it's going to be a list of strings we put in here. And now we're going to specify the output of the two modules we've created above, the HTTP and HTTPS ones, by writing module dot the module's name dot the output name. Note that this is only possible because we defined in the child module that it would output this value. Anything we want to consume in this way with module dot has to be defined as an output in that child module we're calling. We can add the second one here too after a comma, and we'll just change this to HTTP. Now we're good to go. Just to reiterate then, by doing this, what we've said is our two web servers should be allowed into this database through the firewall because they're members of those two security groups, but nothing else. Of course, I keep calling these web servers and database servers. It's not like they actually have any websites or databases on them or anything. They will do as we progress through this course, but all that excitement comes in later chapters. We're just focusing on core infrastructure and operating systems for now. Okay, I'm going to run our golden commands again here, but in the interests of your sanity, because this is such a long section, I'm going to super fast forward the whole thing. There. Another quick check in our web console here. And we can now see the DB server spinning up as well. And a shufti in the security groups confirms that they're there too, just as we'd expect. Now, let's say at this point we're in work, and your boss comes up to you and says, "Good work setting up development, Bernard." I assume your name is Bernard too, of course. "Good work, Bernard. That took you 2 days. Now we want production, so you've got a further 2 days to do the same thing just as well." So okay, we've been asked to do that by the boss, so let's go. First, we'll create a folder for production. Now let's copy all our files from dev in here one by one. Nice and easy. Okay, and now we've done that, let's go into Terraform TFVars, and we'll change the environment name to prod by adding this override prod in the TFVars. And that's it, we're already done. That definitely didn't take us the same amount of time. So now we've got a whole 2 days spare at work to go browsing around on the internet and filling our coffee mug with export strength lager. To make it easy to see the difference between our prod servers and our dev servers here, I'm going to quickly modify the name tag to include the environment. I probably should have done that anyway if I were a good designer. It won't fail if we don't. You can have things with the same name tag, it just won't be as clear what's going on to us. There we go. Finally, so our spin-up doesn't interfere with dev, we need to give it its own backend, so we'll quickly change that to prod too. Okay, let's switch into our prod directory now and whiz through our spin-up again. So, Terraform init to get those 3 modules. Terraform plan. And now as it's looking good, Terraform apply. Another look in the console shows us that we now have 3 identical servers to dev, but handily labelled prod, for our customers to hit in perfect confidence of a stable consumer experience. Glory all around! You can hopefully really see how powerful Terraform is now, for keeping environments the same, for bulk spinning things up again and again without mistakes, and for controlling change. Compare how tightly managed this is with making stuff by hand, where a team is only as good as its worst engineer. With Terraform, your team is always as good as your best engineer, assuming they always cast an eye over every pull request, of course. Right. As always, let's Terraform destroy all of our stuff and check this most epic of sections back into Git. First we'll destroy prod. And now we change to dev and destroy that. Remember, you need to run a destroy in each root folder that you spin things up in. And finally, git status. git add a, git commit with a sensible message, and sing it with me, git push origin master. And you've reached the end of the Terraform chapter. Rather than ramble on about this section here, let's just jump straight to the next section where I summarise everything that we've learned.